Good day, class. Welcome to Playing Tricks in Mathematics. Today, we want to look at another important topic, which is division. We want to look at division of whole numbers, decimal, and fractions in mathematics. We want to see how we can easily deal with division of this set of numbers. Division of whole numbers in mathematics. Let's say you have a question that says solve 675 divided by 5. Basically, the question is just asking us to use 5 to divide 675. You can write the question like this: 675 over 5. Don't forget, this sign is the same thing as division. I've explained that in our previous video under basic operations in mathematics. If you still don't understand what I just did, you can go and watch the video again. Now, how do we start? We start asking questions. We want to go with the simplest method, and that is the essence of this video. Now, you now say, how many 5 can I see in 6? 1. What do you have left? 1. Because 5 times 1, 5. 6 minus 5. You have 1 left. And that 1 that is left has made this to be 17. So, this is now 17. You now say, how many 5 can I see in 17? That is 3. Right? Now, 3 times 5, 15. 17 minus 15. You have 2 left here. That makes this one to be what? 25. And I say, how many 5 can you see in 25? That is 5. So that is what we call short division process. So using 5 to divide 675 gives us 135. Let's look at another example. 2 divided by 25. Now, this is how we do it. 2 divided by 25. Let's write the question again. 2 over 25, right? So we now say, how many 25 can we get in 2? It's not possible. We write 0 point. This 0 point has given us power to be able to write 0 here, and this is now 20. We ask the question again, how many 25 can we see in 20? It's not possible. We put 0. So this 0 and the decimal point has given us power to be able to write 0 here. This is now 200. Now say, how many 25 can we get in 200? And that is possible. That is 8. So let's check. 25 times 8. 8 times 5, 40. Write 0 equal 4. 8 times 2, 16 plus 4, 20. So that is correct. So, therefore, 2 divided by 25 is 0.08. If you press calculator, that is what you're going to get. But you don't need calculator to solve this kind of division. Just follow the process and you'll be able to get the right answer. Let's look at one example more under division of whole number to understand the division better. Now, let's say you have 9080 divided by 22. This question is also asking us to use 22 to divide 9080. So let's write the question in another way. 9080 over 22. Now let's start asking the right question as usual. Now the question is, how many 22 can we get in 90? Start taking them step by step. You know, I always say to work mathematics or do fine in mathematics, you need to understand how to do things step by step. So how many 22 can we get in 90? That is 4. 22 times 4, that is 88, right? So 90 minus 88, that is 2. So 2 and 8, this has become 28. Then how many 22 can we get in 28? That is 1. 28 minus 22. We have 6, right? So now we now place the 6 here. This has become 60. Then how many 22 can we see in 60? 2. That is 44. So 60 minus 44. 60 minus 44 is 6. We have 16, right? We have 16 left here. Now we now ask the question again. How many 22 can we see in 16? It's not possible. Then we place a decimal point here. Alright? This decimal point has given us power to add 0 to this. So now we now have 160 over 22. So how many 22 can we see in 160? We have 7. Alright? We have 7. So 22 times 7, that is 4, 5, 154. 7 times 2, 14. 7 times 2 again, 14. You keep 1, the one you get plus 14, 154. So 160 minus 154, we have 6 left again, right? We have 6 left again. So because of the power of this decimal point, you can say add 0 to this. You understand? Now say how many 22 can we see in 60? 2 as usual. Right? 44. We have 16 again. Because of the power of this decimal point, we put 0 again. That will be 7. Then 154. We have 6 again. We will have 6 again, right? 6. So because of the power of this decimal point, we put 0. That is 60. Then how many 20 can we see? 2. So it just become, it will just be going like this. So this is what we call recurring decimal, because it will keep on going like that. The number will keep on, number after decimal will keep on repeating itself. That's why we call it recurring decimal. When it is recurring decimal like that, it cannot stop. You just stop at a particular point by yourself. Then our final answer will now be, maybe you want to take it to 2 decimal places. That is 412. Let's take it to 2 decimal places. This becomes 3, we throw it away. This is 7. We approximate it to 1 and add it to this, so 0.73. So you can choose to leave your answer like this because you are having recurring decimal. Now let's go to the next set of numbers, which are decimals. Let's go to decimals. Division of decimals. Division of decimals. Alright. Now let's go by way of examples. Let's say you have a question that says evaluate 302.8 divided by 20. Alright, you have 302.8 divided by 20. If you look at it very well, the first number is a decimal, while the second number is whole number. So let's deal with it straight. Let's write it in the proper way for us to go by way of short division method. 302.8 over 20. To make the division process to be easier, you need to first of all eliminate this decimal point. But before you eliminate the decimal point, you have to know how many places the decimal move before this number will become whole number. So it's going to move 1 place, right? Take note of that because you are going to replace it at the end of the day so that you have correct answer. So we can now say we have 3028 over 20. Now let's start asking the right question. How many 20 can we see in 30? 1. What do you have left? 10. So we write the 10 here. 102. So we now say how many 20 can you see in 102? 5. 5 times 20, that's 100. 102 minus 100. You have 2 left. With that, this is now 28. How many 20 can you see in 28? 1. What do you have left? 8. Now say how many 20 can you see in 8? It's not possible. What do? You place your decimal point here so that you have power to be able to add 0 to this place. Now this has become 80 now. So now how many 20 can you see in 80? That is 4. Then nothing is left. That is the end of the division process. Now this is the answer you have now, but it is not your final answer because before, at the beginning, to make this number a whole number, you have moved the decimal by 1 place. So you have to return it back here. So the decimal has to move 1 place like this. So your final answer is now 15.14. If you press calculator, that's what you are going to get. That is a simple way to divide a decimal number and a whole number. Let's look at another example to shed more light on this division process under decimals. Let's say you have another question. 2. Solve 0.75 divided by 1.5. So this question is different from the one we have just done because this question involves 2 decimal numbers. So now how do we do it? Let's write it in the right way so that we'll be able to use short division method. Now we have 0.75 over 1.5. That means we want to use 1.5 to divide 0.75. How do we do it? The easiest way to do it is still to eliminate this decimal point. But the way we do it under division of two decimals is that we have to go by way of equivalent fraction. What do I mean by equivalent fraction? You know, during fraction in our previous video, I explained that the number written on top or above is called numerator, while the number written below is the denominator. So in equivalent process, what you do to numerator, you have to do it to the denominator, right? So for this numerator to be a whole number, then decimal point has to move 2 places. For this one, it has to move 1 place. So, and we have to go by way of the one with the highest movement, which is this. So that means we are going to multiply this one by 100 and this one by 100. To solve this question, we need to multiply it by using equivalent process. How do you get the equivalent process? You look at how many places will the decimals move. This one will move 2 places to become whole number. This one will move 1 place to become whole number. So we'll go with the highest movement, which is this. So we'll multiply the numerator by 100 and the denominator by 100. Then this 0 will move this one here. This 0 will also move this one here. So we have 0.75. This 0 will move this one here. We have 1.5. Then the last 0 will just write it here. So what we end up having is 75 over 150. Then we start asking the right question. How many 150 can we get in 75? It's not possible. That would be 0 point. So this will give us power to be able to write 0 here. This is now 750. Then how many 150 can we get in 750? That is 5. You can check it. 150 times 5. 5 times 0. 5 times 5, 25. 5 times 1, 5. That is 750. So far, so good. Using 1.5 to divide 0.75, we have 0.5. That is the simple way to approach this kind of division when you have decimal to divide another decimal. So let's move to the next set of numbers, which are fractions. So how do we perform division operation in fractions? Division of fractions. All right. Let's go by way of examples as usual to quickly understand it. Let's say you have a question that says simplify 2 over 3 divided by 4 over 9. Now, under division of fractions, you have to be very, very careful. Under division of fraction, the number or the fraction that follows the division sign, you have to undergo some changes. Now, it will undergo what we call reciprocal. What we call reciprocal process or inversion process. Don't be scared of these two words. They mean the same thing. Now, this is what we are saying. Now, we have 2 over 3 divided by 4 over 9. For us to be able to do this successfully, this division sign has to change to multiplication sign. Then by doing that, this number behind the division sign will have to undergo either what we call reciprocal process or inversion process. That is, the number below will go up and the number at the top will come down. So that is it. So this will now be 2 over 3 times 9 over 4. That is what we mean by either reciprocal process or inversion process. Meaning the denominator will become the numerator, while the numerator will become the denominator. Then you do it in the normal way. 2 times 9, 18. 3 times 4, 12. Right? You look at the number that you have to cut them to the lowest, right? 3 can go here. 3 in 18, 6. 3 in 12, 4. 2 can still go. 2 in 6, 3. 2 in 4, 2. Right? So, therefore, 3 over 2. This is an improper. This is an example of an improper fraction. So, you change it to mixed number. By saying, how many 2 can you see in 3? 1. What do you have left? 1. So, the final answer is 1 whole number. 1 over 2. Or, you can cut it directly. Since you have 2 over 3 times 9 over 4. Yesterday, I said you can move like this. This is division. You can also move like this. This is division. If you move like this is multiplication. If you move like this is multiplication. If you move like this is division. If you move like this is division. So I can move like this and say 2 here 1, 2 here 2, 3 here 1, 3 here 3. What do I have? I have 1 times 3 over 1 times 2. So this is 3 over 2, which is one whole number 1 over 2. Let's look at another example. Example 2. Let's say you have a question that says simplify 3 whole number 1 over 7 divided by 3 over 7. Right? The first thing we do is to convert this one to an improper fraction. So 3 whole number 1 over 7 is the same thing as 3 times 7 plus 1. So that is 21 plus 1 over 7. That is 22 over 7. So we can now write our question and say 22 over 7 divided by 3 over 7. So, as usual, this number after the division sign will undergo a reciprocal or an inversion process, whereby the denominator will become the numerator and numerator will become the denominator. So, we now have 22 over 7 times 7 over 3, and this will be 22 times 7 over 7 times 3, right? Now, 22 times 7, this is 4, 14, another 14, 15, 154. So this is, so now be 154 over 21. How many 21 can we see 154? 7. 21 times 7, 7, 14. So that means 154 minus 147, this is 14, minus 7, 7, 4, 0. So this is 0. So we have 7. So this will now be 7 over 21. As you can see, 7 can still divide 21. 7 here 1, 7 here 3. So our final answer will now be 7 whole number 1 over 3. And you can also take a short way after you have arrived this level by saying 22 over 7 times 7 over 3. Like I said the other time, that going like this is division, going like this is division. So you can say 7 here 1, 7 here 1. So what do you have? 22 times 1 over 1 times 3. So this is now 22 over 3. So how many 3 can we see in 22? 7. What do you have left? 1 over 3. Let's look at another example to understand the concept well. 12 divided by 3 over 4. This one is different from the one we have done because this is a whole number and this is fraction. The first thing we do is to convert this whole number to fraction. So this is 12 over 1 divided by 3 over 4. Then the number after the division sign will undergo reciprocal process or inversion process. That is, the denominator will go to the numerator, numerator will come to the denominator. So we have 12 over 1 times 4 over 3. Don't forget this when you are working on division of fractions. Now, can I go by way of saying 12 times 4 over 1 times 3. So 12 times 4 is 48. Then this is 1 times 3. 1 times 3 is 3. So let's look at what can divide to take it to the lowest level. 3 here 1, 3 in 4, 1, remain 1, 3, 18, 6. So we have 16 over 1. So the final answer is 16 because 16 over 1 is 16 as 16. Or you can, from this level, you can say 12 over 1 times 4 over 3. You can divide this straight by saying 3 here 1, 3 here 4. So you have 4 times 4 over 1 times 1. This is 16 over 1. And the final answer is still 16. So that's another way of working division of fractions. Let's look at the last example under this set of numbers. Let's say you have a question that says 4. Solve 2 whole number 1 over 10 divided by 2 whole number 2 over 5. Now, this question is different from the other ones we have done because this involves 2 mixed numbers. So the first thing we do is to convert the mixed numbers into improper fractions. So let's take the first one. 2 whole number 1 over 10 will be 2 times 10 plus 1. So 2 times 10 is 20. 20 plus 1 is 21. So this is 21 over 10. Then 2 whole number 2 over 5 will be 2 times 5 plus 2. 2 times 5, that is 10, plus 2, that is 12 over 5. Then we can now rewrite our question like this and say 21 over 10 divided by 12 over 5, right? So the number behind the division sign, we have to undergo inversion process or reciprocal process. So the denominator will go to numerator, numerator will come to the denominator. So this is what we are saying. You now have 21 over 10 times 5 over 12. You can go by way of saying 21 times 5 over 10 times 12. So 21 times 5, 10, that is 105. And 10 times 12 is 120. So now we have 105 over 120. You can decide to cut to the lowest. 5 here 2, 5 here 1. 5 in 12, 2, remain 2. 5 in 20, 4. So we have 21 over 24. 3 can still cut this one. 3 in 21, 7. 3 in 24, 8. So the final answer is 7 over 8. Or you can go the other way around, times 5 over 12. You can say 5 here 1, 5 here 2, right? 3 here 7, 3 here 4. So what do you have? 7 times 1 over 2 times 4. So you have 7 over 8. So you can see that the two answers are the same. So far, so good. That is how to perform division on whole numbers, decimals, and fractions in mathematics. Thank you for watching and listening. Please like this video and other videos on our YouTube channel. Make your comments. Kindly help to share the videos and subscribe to our channel. See you next time.